We will solve this today's LeetCode problem. This is LeetCode medium binary search tree to getter sum tree. So the question is, given the root of a binary search tree, convert it a greater tree such that every key of the original BST is changed to original key plus the sum of all keys greater than the original key in BST. As a reminder, binary search tree. So there's a definition given binary of search tree, right? So basically, binary search tree is that BST is what? BST is something like that the node, the every node, each and every node which is in the which is in the left of subtree is must be less than subtree is less than the current node, the parent node key, right? That's the and each and every node which is in the right of each and every node which is in the right of subtree is will be greater than the current node, right? Right of subtree will be greater than the parent node key value, right? This is the definition of binary search tree which is given in the here. The left subtree of a node contains only nodes with key less than the nodes key, and the right subtree of a node contains only nodes with keys greater than the nodes key, and both left and right subtree must be also a binary search tree. That's the three conditions of a BST, right? So, if you see the question, we need to convert the given BST into a greater tree such that every key of the original BST is changed to the original key plus the sum of all the keys greater than the original key in BST. Means I need to change this key, this forward key, to by the sum of all the keys which is greater than this original key. What does it mean? It means we need to change this 4 to all the values by taking the summation of all which is in the right key, which is, if you see in the example 4, this example 1, in this 4, this 4 key will be the summation of all the keys which is in the right, because we know that BST property, that the right subtree of a node contains only nodes with keys greater than the nodes key, right? So it means we will only find all the nodes which is greater than the original key at the right position. Okay, so one thing is clear, that I need to definitely see definitely see at the right of the node, right? Node key, right? One thing is clear, right? Okay, so if we see in the example, this example 4 and something like this, so let's take this example, right? uh, let's take example 4, then 6, then 7, then 8 and 5. So if you see this 4, if you take all the summation of these numbers which is in the right, 6 5 7 8, 6 5 11 7 18 18 8, 26, 26 plus 4, this is 30, right? So see, this 4 is changed to 30. If you see in the output, we have 130 number, right? So this 4 is changed to 30, right? Also for 6, this for 6, so for this 4 we don't need this left elements, because these are all the elements which are obviously left, which are obviously less than this 4, because we know that the property of the subtree, that left subtree of a node will be always less than the node key, and we only want the original BST to be changed to sum of greater than the original key, right? So we will look into on the right. So if you look into on the right, it becomes 30, right? Okay. Now the second thing needs to be observed here. That the number which is in the left, suppose this is one, right? So this one values. So this one, all the values which is in the right, including its parent, all are greater than this one. Can you observe this? Can you see this, right? This one is all this one all the elements which is at the right of this one or its parent is always greater than this one, right? So it means the 4 number which is at 30 must be included in this one also, right? Also this one right position is also greater than this one, right? So it means the second thing is that I need to see at the right of the node key. Also what I need to see, also I need to see its parent values after modification. Why I'm telling that? See, this one parents must be greater than this one if it is the left position. if the key is at left position of any node value, right? If any node value of its parent value, of its parent value. So it means when any node is at left of its parent value, it means I need to check its branches also, its right branches. Also, I need to check its parent value, because if it is at left of any parent value, it means the parent value will always be greater than this node's value, right? So it means I need to check its right branches also, plus its parent value also. But you need so the second thing is that if the key is at left position, let's write this at first position, right? Because this is the main point. If key is at the left position of its parent value, then i also need to I also need to see its parent value after modification. After modification means after taking all the right elements and update this 4 to 30. Then I need to check for one. Also need to check, see its parents value plus its right branches, plus its right branches. That's the two things you need to see here, right? Okay. So basically this is the mainly questions I need to see, right? If you want to solve this, you can solve this with these two key points only, right? If you can solve this with two key points only, I just want you to go and remember these 2 points and try to solve the questions, and means try to implement. If you're not able to solve it, come then come later, right? So this is, so suppose now how this is working. See, this 4 will go to will see its rights value, right? This 6 will see its rights value, 7 will see its right value, and 8 have no right on no left value, right? It's a leaf tree, right? So see, 8 is becomes 8, right? But this 7 has greater elements, it has its right value as 8. So it means this 8 needs to be some to this root value, which becomes 15. If you see here, it becomes 15, right? Now the 6 value right position is 7, which is already modified 15. So it means this 6 value should be modified with this 15 by taking summation of that. So 15 plus 6 is 21, which is here, right? Now the observation is 6 left value is 5, right? 6 left value is 5. Although it's a although it's uh, a leaf root, right? So it's don't have any right branches, so this part gone, right? And also I need to see its parents value, because it is a left, it is in the left of parent. So if you see in the parent part, this is 21 already after modification, right? So it needs, this 21 needs to be added with 5, which becomes 26, right? Now the observation is this 26 is a whole summation of this tree, this right branch, right? And this 26 needs to be sent to this 4, because this is ultimately in the right of 4 now. This is left of 6, but it is ultimately in the right of 4 now. It means it will be definitely greater than this 4. It means what does we observe, what does we observe? We need to move in right, then we move in root, and then we move in left, right? If you see this, we move in right, right, then root, then left part, right? See, this 5 is at last position, which is at left, so 26. And when we go to this 4, this 26 will summation to this 4, which is become 30, right? So if you see, we go out at right, then we move to root, every part of root, then we go to left, and after this 4, which is become 30, we will move to its left. So when we move to its left, it's become 1, right? It become 1, and this 1 will needs to check its right values also, right? Because this value should take greater than values, so it needs to check its right branches. So if we take right branches, this is 2 and this is 3, the same process again which we have done here, 6 for 6 7 8, the same process for 2 3, again this 3. So but the problem is here, the main thing is here, that this 30 needs to be added in all of the left root, because this 30 will be always greater than this all of them, 0 1 2 3 and all. So it means this 30 will be added to 1 also, this 2 also, this 3 also, this 0 also, right? So it means if you see 3, this 30 plus 3 is 33, and this 3 needs to be included here 2 also, which is 5 to 35, and this 35 plus 1 36, and this 0 should include this one part, right? So that would be 36 plus 0, which is 36. So basically, if you see, we need to move in right root and left. So if you observe this, this is something like reverse of left root right, right. And what is this? What is it? This is a in order traversal. In order traversal. So basically, this is a in order traversal. This is a in order traversal. This is a in order traversal, right? This root left root right is the in order traversal. It means this is this is reverse in order traversal, right? This is a reverse in order traversal. So basically, the question is now only left with, the question is now the question is just to implement reverse in order traversal. And we and this is the very basic in order traversal. You must have solved it. If you not, please please watch in order traversal video, right? It's just a right, left, go to left, then root, and then right. Just think, this is the in order traversal, and we here see that we need to move it right, then root, then left. So what we will do, we will maintain a sum value. What we will do, we will maintain a sum value, right? Because ultimately I need to change the value of all the nodes, right? So if I take this example, the 7, or we take this one, okay, let's take the 7, right? It will take time to create this tree, but no worries. So this will be 8, right? So 4 6 7 8, and this 6 will be form, this 6 will form this 6 will have a left node, which is 5, right? Which is 5, right? Again, this 4 will have also some left node values, which is, what will be that? That would be 1, right? That would be 1. So this one and this node, right? So this one will give us right part is 0, and the left part is, okay, okay, just give me a second. uh right. So right part is 2, right? Okay. Again, two's right value is 3. So this is 3. Okay, just give me a second. Two's right value is 3, right? Now the tree is made it, right? Now, let's give some spaces, right? Which will look better. So this is the tree which we have. And now if you see, we need to maintain a summation for that, right? So basically, if I start from this 4 part, and I need to move it from right, right? So we need to start from this 4, and we need to move it right, then root, and then left part. So when I start from the right part, this 4 and this 6, so we will move from 4, then go to till 6, then 7, this 8, because I need to start from the right. So I will move its whole right, and then we'll go to from 8. Now the thing is, when I reached its limits 8, I need to return back. Right? And if I return back, this 8 needs to be included this 7, right? This needs to be included in 7. This left, when we go its right, its left part and this right part is null, right? Its left part and the right part is null. It means from right is null, we will return it. From root, now root we have a root. It means I need to add this value. So what I will do, I will take a variable sum, a global sum or something like, and I will add this 8, right? Okay, this part is over because its left is also not. We will return from here, we will bounce back to 7. Now the 7 has needs to be included this 8. And in the summation we have already a 8, right? We have already 8. It means I will just add this 7 to 8, which will become 15, right? Which will become 15. The same thing which we have seen here, that how will I determine this right root left. the same thing will be gone, but how will I how will I change this value? That's the main thing, right? So what I will do, I will just use a summation value to include all the summation in my answer. We will see that how this is working. So this is 7 and 15. Now this 7 needs to be bounced back because this left value is nothing, right? And we have included this right value from, because we have come bounce back from its right value again. So let's or again just we don't have a left value, and we will bounce back to 6, right? Now the 6 needs to be included with this 15 because its right value should be added, right? So okay, one thing is here, when we started from this right value, when we started from this right value gives me 15 because this summation needs to be added, right? Now this root should be, root value should also be added to his, that's why it becomes 15, and that's need to be added here, that's needs to be updated here, because ultimately I need to add this summation to each values now. Ultimately I need to add this summation value, so this value which is updated at root needs to be updated to sum also, right? Now this 7 will bounce back to 6, right? And this 6 will include this 15 value because it is the value of its all the rights values. So I will include 15 plus 6, which is will be 21, right? Now when I added this root value to 21, this summation should be updated, so I will update that. Now I will move to its left part, right? So basically what this sum representing, sum is representing the summation of all the nodes value which will be in the right, which will be greater than the current value. And why is it happening? Because we have started our traversal from right, then root, then left. So ultimately I am traversing from the greater elements to less elements, right? I'm starting from greater element to less elements in decreasing order, right? So that's why it will be represent always, it will be the summation of all the nodes value which will be greater than the current value, always it will be greater than it will only add those values which are greater than. If you see here, this 6 is included 21, and when we move to its left, this 5 value will added this sum value which will become 26, right? That will become 26, right? This will become 26, right? So this 26 needs to be updated, so I will update it. Now we will bounce back to 6, and this 6 is already been done, right? So 6 will bounce back to 4 now. Now this 4 value will again get summation with 26, so that will become 30. 26 plus 4, now this sum will value also needs to be updated, that would be 13. Now again the same process to right values, all things are over for right values. Now we'll move to one value, right? Its left part. So its left part would be 1, and also we have some 30 which is greater than all the elements from 1. So this 30 needs to be included in this one, so it becomes, so this okay, one thing also, I need to move when I go to one, I needs to move its right value because ultimately I'm not including this one right now because we need to move it right, right? So I'm not including this one right now. This sum is 30 till now, and I will move from one to right value which is 2 because it has a current right value child. So we will move to root. It has also a right child, so we will move to it 3. Now this 3 has no right child and left child, so it means it needs to be updated. So the sum value is 3. This sum value is 3, and this sum is also 30, right? So, and the 3 is a no root value and the sum is 30. It needs to be updated, so it becomes now 33, right? And this sum should also be updated. So we have moved to right, which is a null value because it's don't have a child. Then we will move to root value. Now we will move to left value, which is again a null value. So it's a 33. Now we will bounce back to 2, right? Now this, if we bounce back this 2, what we got, the right value is already over. We will move to its root value, so I need to update it. So that will be 33 plus 2, which is 35. That would be 35. So let's write it here. uh, yeah, that would be 35, right? That would be 35. Now this right part is over, left part is null, so we will bounce back to 1. Now this 1 will include this 35. right? This 35. So this 35 will included in this, so that would become 36. Now we will move to its left part because root part is over. We will move to its left part, and that would be 0, and 0 is root leaf root, so that would be the left and the right part will be the null. So that would include only the root value, which is 36 plus 0, which is 36 only, right? So ultimately we got 36 as an answer. And if you see, we have changes all the modifications in this fashion, right? So that's how we will change this all the roots. So what we do, we have just move in reverse in order traversal and updated all the values with the help of this summation value, which is representing the sum of all the nodes value, which is will be greater than the current value. This the same thing which will be implemented here using the the basic template of inversal in order traversal in reverse order fashion, right? So basically, let's try to just implement it. So if root is null, we will simply return root because that does not have to be iterative in traversal. So let's just make a sum value, and either you can declare globally, or you can pass it by reference. That will be the same thing. And I will pass this. I will go to this solve function and move this root and the summation value. Ultimately I need to return root, right? Because I will change all the values to this root values only, right? So I will just change this root and return root, right? So this will be a void function because I'm not returning anything. The first thing is I will pass root. Now I will pass this sum as by reference because I need to change it dynamically. So I will pass it by reference and use it in my all the nodes to change it. Either you can declare it globally, or you can pass it by reference, right? So that its value don't change by these functions, right? So let's just implement it. So the first condition would be that if the current node is null, so we will just return it from here. Otherwise, what I will do, how will I move? I will move to its right value. So I will move its right values. So first thing we need to check is whether its right value is present or not. So if it's present, I will move its right value simply, and the sum value, right? The second thing, I need to change when I move to rights. So I assume that all the right positions. So this will definitely changes that all the right positions is modified. I'm sure of that. And now what I will do, I will comes to its root part. Now this root part should be added this some value, right? So what I will do, I will change this root value plus to some value. If I change this root value to some value, it means that root value is modified. And now this summation value should be also be updated here because it is representing the summation of all the nodes, which is will greater than the current node. So if 7 has added 8 and it becomes 15, this sum should also be 15 for its left part or for its parent elements, right? So this sum should be now equals to root ka value, because root value is already updated, so I can reassign the sum value to root value, right? Now what I will do, I will need to be moved its left branches if it is available. So what I will do, I will just iterate in root left and the summation. So do you think that this summation would have benefit us? It has a benefit because this sum is updating dynamically, and it is passing by reference. It means I don't need to change it again and again. That's why I have passed it by reference. And this sum representing all the numbers which is greater than uh, a summation of all the numbers which is greater than the current number, right? So that's why I have updated this sum to root value, because when we go to left value, I need this sum value, right? Which will be added. So this is how we just solve the question, and we have updated this at this point. So what we do, we have just move in right value, then we updated the root value, and then we go to the left value, which is just a reverse order traversal. If you just opposite this, that would be an in order traversal, and this is just a reverse order traversal. And ultimately we have written a root. So this is how we will solve the question. Just try to run this. uh, this root value, what's the expected expression? I think this space is some spaces. Yeah, we have passed the sample case. Let's try to submit it. I hope this is correct. Yeah, we have passed all the cases. So simply it's a reverse in order traversal, nothing else. It's just a thing that you need to observe that how is it, how the traversal will go, and that you just see that it's a root right root left, which is just in reverse in order traversal, and we will implement the function. That's all, right? So again, the time complexity would be, so the time complexity is that if you see here, we are moving in, we are going to each and every node once only, right? We are moving in each and every node once only. So that would take definitely O of n, where n is the number of nodes present in BST. So that would be O of n. And if you also consider the recursion stack space, recursion stack, so that would be O of n again. But ultimately it is O of n. So n is the number of nodes present in BST, right? And the space complexity would be, so if you take recursion stack space, so that would be O of n. But if you don't take that, and if you solve it by using iterative, so that would be definitely be neglected. So if you don't take recursion stack space, so that would be O of 1, because we haven't uses any extra spaces. But if you consider auxiliary stack space, so that would be O of n. So let's specify this, right? So auxiliary stack space would be O of n, otherwise it will be O of 1 only, right? And if you don't consider, so consider this, because we have used recursion, right? So that would be O of n. So yeah, thank you so much. Bye bye.